Greetings. Last video for this unit, limits. So it's an infinite limits. Infinite limits. Similarly, plastic glasses, hot water heaters, other oxymorons. This is a picture of the ocean, which is about as close to something infinite that you might imagine. So let's talk about it. Let's consider. It says 2. F of x equals 3 over x minus 2. We know that we're going to have some issues with that when x is equal to 2. We know that it's not going to be continuous, fitting in with what happens. What we want to look at is the behavior. Well, we can see the graph of 3 over x minus 2 goes like that. If we take numbers that are really, really close to 2, say we look at it from above, we take a number that's slightly bigger than 2, we're going to end up with 3 divided by a really, really small number, right? And so that's going to turn out to get really, really big, really, really fast. So big that we probably would call it infinity. Okay. If we look at it from below, look at the limit as x approaches 2 from below, or from the left-hand side, or from a value less than 2, we're going to end up with some negative number on the bottom. Really small negative number. As we divide 3 by a really small negative number, closer and closer to that, getting closer and closer to 0, we end up with a really large negative number. So large that we would probably say that it's approaching negative infinity. Okay? So generally speaking, what we're going to end up saying is, that the limit as x approaches 2 is plus or minus infinity, positive or negative infinity. So which is slightly different. The other day we would have said it does not exist. So when we're talking about an infinite limit, such as we make a statement like we just did, that the limit as a function approaches a value as infinity, either positive or negative. Doesn't mean that the limit exists. We haven't changed that. The limit doesn't exist. We're still showing unbounded behavior. But what we're doing is we're describing how the limit fails to exist. We're getting a little more specific about the failure of the limit. So that's probably going to be, if we get to a place where we see that unbounded behavior, we want to describe the unbounded behavior. Is it heading off to infinity? Is it heading to positive infinity, negative infinity? So we want to be a little more specific. If we look at a problem like this, okay, the limit as x approaches 4. We know that's going to be an issue for us. So let's look at what happens in the positive and negative directions. If we look at the limit as x approaches 4 from above, from a bigger number than 4, from the right if you like to, this is going to be a positive issue. 4 minus 4 is still going to be positive. 3 divided by a really small number is going to get really big in a hurry. So there's that piece. If we look at the limit as x approaches 4 from below, going to get the negative situation. 3 positive divided by a really small negative is going to get really small or really large really fast. So we would say that the limit of that function is positive or negative infinity. With me? Let's look at this one. The limit as we approach, in this case 3, from above, is going to be slightly larger than 3. Subtract 3, going to get really close to 0. Square, we're going to get even closer to 0. 2 divided by that number, we're going to head off to infinity. We say equals infinity, but it really isn't equaling infinity because we can't. The limit as x approaches 3 from below, a negative number, right? Square, we get the positive number. 2 divided by the positive is positive, so sometimes the limit is just positive infinity. Okay, onward we march. Let's check to see if you know what we're doing here. All right, so here we go. So the limit as x approaches 8 of 1 over x minus 8 is that. You agree? Shake your head. So if that's the case, why isn't that true? The delay is killing me. Let me try it again. So if that's the case, why isn't that true? Oh, we're supposed to rim shot. Really? Oh! Whoa! That was a loud one. Well, you're probably laughing for the reason I meant you to be, but we'll go forward on that one. I don't know if that was worth the setup, but we'll go with it. So related to infinite limits are vertical asymptotes. If the function heads to infinity as x approaches a number, then x equals c is a vertical asymptote of my function. So whenever we have some sort of infinite limit, we probably have a vertical asymptote going along. And the asymptotes of value that the function approaches but never quite never quite gets to. So when we're looking for vertical asymptotes, we're looking for values of x that are going to make the denominator equal to 0, which is going to make my function head off to infinity. And so in this case, where might I find myself a vertical asymptote? That's correct. I heard you. When x equals -1, we're going to have a vertical asymptote, which we like to abbreviate VA. Good? But here, where might we find vertical asymptotes on this one? It's going to make the denominator equal 0. Don't just go 1. I know that's right immediately what you're going to do. Think about all the possibilities. X squared plus 1 we can't factor, but we can quickly and easily and efficiently factor the difference of two squares because it's our favorite. Is x plus 1 over x minus 1 gives me vertical asymptotes at +1 and -1. Okay? Found us a vertical asymptote. It's very helpful, you know, when we get to curve sketching. Cotangent. Where are we going to find a vertical asymptote of that? Remember what cotangent's equal to? Cotangent of x is equal to the cosine of x over the sine of x. So we're going to find vertical asymptotes whenever the sine of x is equal to 0. And that happens when x is equal to 0, pi, 2 pi, 3 pi, n pi, any number of pi's that we have. Right? So we're just looking again, what's to get ourselves a vertical asymptote, what's causing the vertical asymptotes, the denominator going to 0. Here's one for you to try. And don't wait for the magically to appear. It's not going to happen. Okay, it's going to be appearing tomorrow when we come to class. So try that out, find some vertical asymptotes of that thing, and we'll talk about it tomorrow. Good enough? Good. So properties of infinite limits. I have two functions. One function, as x approaches c, its limit is infinity. The other function, as x approaches c, its limit is L being some number. Okay, so what's the limit if I add the two functions together? Did anyone say infinity plus L? Hopefully not. Okay, so it's infinity. Remember, infinity is a concept, it's an idea. If we're at a place where we can still add a number to infinity, we're not at infinity yet. So like the playground stuff where you used to go, first, you know, infinity plus 1, that sort of thing, doesn't work. Because if you're at infinity, you can't add 1 to it. Because if you can add 1, you're not at infinity. It's an idea, it's a concept, it's far away. What is the limit of the two functions multiplied together? Using our properties of limits, we would just multiply the two limits together, right? So L times infinity is still infinity, right? Right. How about if we do a division? We get L divided by infinity. What happens when we take L, some number, and we divide it by infinite number of pieces? Take something and divide it into an infinite number of pieces. That hits to 0. 0. Okay? So, can't have infinity plus 1. Here's a question for you. Well, let me ask you, remind me to ask you tomorrow about the end of the universe. Okay, I always wonder about what's outside the end of the universe. All right, here's a little problem for you. As x goes to 0, what's the value of 1 plus 1 over x squared? As x goes to 0, this gets really, really small from either direction. 1 over really, really, really small is really, really big, right? Really big plus 1 is still really, really big. So our answer is infinity. I think that's the end, yes. All right, so infinite limits. Again, they're not telling us how the limit fails to exist. They're not telling us that the limit exists. They're telling us how it fails to exist. We're just being more descriptive in our description of how we describe the description of a limit failing to exist. So that's what an infinite limit does for us, and that really is about all I've got to say. So work through that problem that I left for you. We'll talk about that tomorrow. We'll talk about the end of the universe and other things as we see fit. So thanks for listening. Hope you learned something. Hope you picked something up. Hope it made some sense to you, and bring some questions tomorrow. Thanks for watching. We'll talk to you soon.